Well, thank you very much, James. Thank you for that introduction, and it's great to be back here at Imperial. I'm sorry I don't have the President of Korea with me this time, but I will do my best in her absence. And I really appreciated the opportunity to deliver this Briscoe Lecture because it gave me the challenge of thinking back, trying to make some kind of sense of what I did during my years in government, where space was amongst my ministerial responsibilities, but look back further than that and put space into a strategic and security context, which is often left to the security and defense specialists, but actually has so many interactions with wider civil space policy that I thought I would give it a go. I'm going to take a historical approach, so I'm going to start at the beginning of Britain in space, which was April 1962, when we launched Ariel 1, our first satellite. Well, I say we launched. It was launched for us by the Americans from Cape Canaveral, and quite a lot of the technology in it was American, but there was some British science, and we do claim it as our first British satellite, up there because of the Americans. 3 months later, the Americans conducted a high-altitude nuclear test and knocked the satellite out. I always say this is a case study in the special relationship. So that's how it started, and it set some of my themes for the conference. At the same time as having this very close dependence on the Americans, we were trying to develop our own launch system, Blue Streak, a medium-range ballistic missile, which was intended to deliver our nuclear deterrent as the Vulcan bombers came to the end of their life, using a Commonwealth launch base at Woomera. But it wasn't robust enough for military use, and that role was abandoned in 1960, and instead we went for the US Skybolt system, which in turn became Polaris. But Blue Streak was still thought usable for civil purposes, where you didn't have to have it on permanent standby, where you could plan a time for launch. And so the plan became to develop Blue Streak for civil purposes with our Commonwealth partners, Australia and Canada. But that fell through. They hadn't got the funding. They weren't confident in Blue Streak. And so after having given up on the military use and turned to the Americans for that, having tried Commonwealth cooperation but not being able to make that work, we reluctantly offered it as the basis for European cooperation. And it became the core of what was then created as the European Launcher Development Organization, or ELDO, which was one of the two progenitors of what became the European Space Agency. So our old rocket launch technology became the first stage of ESA's original launcher, Ariane. But we played no further role in either developing it or funding it. So we are the only spacefaring nation to have had a launch capacity, to have renounced it, to have then given it to other countries with whom we had no security relationship and played no further part in its development. We've ended up, for the decades since, depending on others for our launch capacity. And that accident, which I've described the series of historical accidents, has turned out, you could argue, to be quite a smart strategy, because we've ended up specializing not in launch vehicles, which are incredibly expensive and where it's hard to make a return, but in satellites. And we manufacture over a quarter of the world's big civil satellites in places like Stevenage and Portsmouth, now mainly through Airbus, which was Matra Marconi, and BAE Systems, which BAE Systems in one of their convulsions kind of pulled out from it, but Airbus end up acquiring a lot of that capability. And because we don't have our own launch system, it is no accident that we're the nation that has produced the Hitchhiker's Guide to the Galaxy. We're always trying to cadge a lift on someone else's launcher. And the fact that you're having to pay a lot of money and endlessly finding someone else who will launch your satellites for you has given us a real incentive to go for low weight and therefore low cost satellites. And we have become the world leaders in small satellites. I remember having a conversation with the cosmonaut who spent longer in space than anyone else, Krakovlev, and saying to him that, of course, we in Britain were proud of our small satellites. He said, oh, yes, I remember your small satellites. I launched a few of them. I threw them out of the back of the space station, which is one way in which you can indeed launch them. But actually, what normally happens, if you think of the capsule at the top of a big rocket, you have a great big sphere, a classic big satellite. And then if you think round the edge, there is a void. Where what you can do, and they are simple mechanical devices, you can put a small satellite in a mechanical system with a metal spring, and at the right point, you just push the spring and the small satellite launches out. And that is how many of Britain's great satellites have been launched, on a little spring pushing them off the side of the launch of a much larger satellite. Now, I should declare an interest here. I've just joined the board of Surrey Satellites, which is one of the main manufacturers of small satellites, and which has its origins, interestingly, in the University of Surrey. It's one of the country's most successful university spin-outs, and now part of Airbus. So we have specialized in satellites, not launch systems. And when it comes to launch systems, these big, expensive launch systems are, I think there's a general view in the industry, facing quite radical technological change. The saying goes that when it comes to space, the 21st century begins in about 2020. That's when you have a range of diverse, innovative launch systems where the technologies for small and even smaller nanosats develop, and you begin to see a rather different type of space range of space services than we've been used to over the past 50 years. And Britain, again, because we aren't committed, we haven't got any sunk costs in big conventional launch systems, we have put a lot of effort instead into innovative new technologies, notably the reaction engines project, the Sabre Engine, which I was pleased to put some funding towards during my time as minister, which uses, instead of taking up oxygen to burn the fuel, extracts oxygen from the air as it's going through the atmosphere to then burn the fuel. And to do this has a quite extraordinary technological achievement of cooling the air from 1,000 degrees centigrade to minus 150 degrees centigrade in 1/100th of a second, which is a very impressive technological feat. This was a model that was known in principle, in theory, to be a way of delivering launch, but it looks as if our scientists, led by the great Alan Bond, have cracked the challenge. So I think that paradoxically, that sort of story of accidents has ended up with Britain in rather a good place as we enter the next generation of space, with innovations in launch technologies, expertise in small satellites. To be honest, my vision was that we would end up, within a decade, having a full space capacity, having a spaceport, and we launched a consultation on the location of a spaceport, having our own launch technologies, clearly having the capacity to make our own satellites, so having a full integrated space capability. Of course, it's only where you can't just do that out of national pride. You have to do it only if there are commercial and security benefits, and in particular if you value the kind of autonomy that that gives you. And that leads me back now into the history of the strategic issues in space. I began my career as a Treasury official, and one of the things we always used to wonder as we were looking at public expenditure and the amount of public spending we had to put into our nuclear deterrent, we always wondered how the French seemed to get their nuclear deterrent so cheap. We could never quite understand how they could afford it at apparently a significantly lower cost than we could. And during my time as the space minister, I finally realized something which the experts, I think, knew all along. It's because of Ariane, because most of these projects have both a civil and a military purpose. If you develop some of these technologies, they are classic dual use. And Ariane, of course, originally, as I described, beginning with us, but now handed over to the continental Europeans with our not playing a part in it, is actually largely funded by Germany, though with a substantial French contribution. So the paradox is that what had begun And what was abandoned as part of a developing special relationship between the US and UK instead became the heart of a different special relationship between Germany and France. And that's why the most recent dispute between them about how Ariane should be modernized mattered so much. And in fact, it spilled over into the ESA Council of November 2012, when there was a major row where the Germans tried to save money by going for incremental improvements in Ariane 5, and the French wanting much more ambitious investment in the next complete technology, Ariane 6. That Franco-German dispute, which bedeviled the run-up to and that council, gave us a strategic opportunity to become once again a serious European player by being fully engaged and constructive, whilst France and Germany were distracted by their argument. And incidentally, the French eventually got Ariane 6. They got their way. What we got at that ESA Council was we were able to, with the support of the Chancellor, I was able to increase the British contribution to ESA, which enabled us to argue that ESA should move a significant research facility to the UK, which they've done at Harwell. And we also secured an official flight for Tim Peake to the space station, which will be happening in 6 weeks' time or so. The first major official mission by a British astronaut. For a financial contribution to the human spaceflight program, which I think is rather less than the cost of the fuel that will be used to get him up to the space station. So it was a bargain as well. And I see that as another example of how space policy and diplomacy and security policy come together. It shows that if you turn up and try to be constructive, try to be part of the solution, not part of the problem, you really can make progress. And that, I think, is actually true to our history, because if you look back to the origins of ESA, ELDO, the Launch Development Organization, and the European Space Research Organization, ESRO, merged to become ESA in 1975, and its first director was Roy Gibson, who is still alive, a great man, and who played a crucial role in creating the ESA we recognize today. ESA, the European Space Agency, is not part of the EU legally, and it is not like the EU organizationally. It is a true intergovernmental organization. And given that we're having such a lively debate about Europe at the moment, it's also fascinating to contemplate what an intergovernmental European model looks like as against the confederation that we have in the EU. And again, I was able to observe this close up. The first thing to understand about ESA is that its funding model is not like a European program, in that it has a pretty clear and stark principle of juste retour. That what you pay in is what you get back out. There has to be some competition, there has to be some technical capacity there, which requires a lot of assessment, but essentially, whatever your contribution to any given program, you will get broadly that amount of industrial work out of it, which is not how EU programs are automatically allocated. And what this means is there is an industrial opportunity if you play your cards right. Because what ESA does, ESA is the R&D agency. ESA does the prototyping. So what you do is that you pay a substantial amount up front to get a big industrial component of one of their R&D programs. And then if it works, and of course sometimes that's not at all straightforward, when it works and it moves from being an R&D demonstrator to being a relatively mass-produced satellite system for another agency, EUMETSAT, for example, European Met Office, at that point, ESA hands it over, and the other agency then procures 3 satellites or 5 satellites or 8 satellites with the same mix of industrial inputs as you have paid for when you contributed to the ESA R&D program. This model is not hard to understand, but Britain was surprisingly reluctant to play that game. But we have done so with rather more success in the ESA councils in 2012 and 2014, led by my successor, Greg Clark, and with the active engagement of the Chancellor. EU, by comparison, is actually a more free market competitive model than ESA. is. And indeed, because in the EU, when they look at this ESA model, they're very uncomfortable with a direct juste retour way in funding space projects. And this is actually a source of tension between the EU and ESA. The 2009 Lisbon Treaty gives EU competence in space, and one of the issues that then arrives is how contracting for space projects should be done. So the problem is that ESA, the intergovernmental model, has too much in-house capacity and is too focused on juste retour for the free market liberals of the European Commission. So I regard it as a fascinating case study in the tensions between intergovernmentalism and confederation. We can now play a crucial role in ESA, in particular in the multinational space science projects, which are beyond the ability of a single nation or a single business to support, where the technical development of Europe's space structure really is important: navigation, telecoms, Earth observation. So that's the European angle. Now, what about the special relationship with America? How does that fit in? So we're now in a position where for us the key space security relationship is with the US, whereas for France and Germany it is with each other. And that led us, the cumulative effects of all the policies I described earlier was to lead us increasingly disengaged from a wide range of ESA activities. We weren't engaged in launches. We had decided not to do manned flight, though that was a decision that I reversed. And we were not involved in security issues linked to ESA projects. And this semi-detached relationship to ESA, I think, was putting us at a disadvantage in securing a prominent and significant role in shaping its future. And that, I've already said, we went back into the MAN program. The other issue was to what extent we should engage in ESA's security issues. And that's what I'd like to turn to, because, of course, we do feel the gravitational pull of the US, and they provide us with a lot of the data obtained by their satellites, which is not shared by the US with other European partners. So we get access which is not available to the rest of Europe. As a junior minister in John Major's government, I can still remember vividly being present at a row during the Balkan crisis, which brought this home to me. The German government had committed their military to the peacekeeping operation in the Balkans. And I witnessed a German general complaining to a senior representative of the US government that they were not getting all the satellite information they needed and which they knew the Americans possessed to enable them to carry out their military operations safely and securely. And the US administration official explained that there were limits to what they could share. The German general replied that if they would not provide that service to Germany, then Europe would need to develop their own capability. And that is part of the background to the emergence of projects such as Galileo and the German-French Helios military Earth observation system. We are in a different situation. So we get the access and the fruits to America's capability. And that lack of a security need of the same significance left us cautious about some European initiatives which were mattered far more to our other European partners. And this helped me understand some of the drivers of industrial policy, one of the things that I worked on in BIS. In fact, I increasingly came to see our dependence on the US for a whole host of key security related services as one reason for our blindness to how industrial policy works in other major Western countries. If you are a continental European power, like the Germans and the French, you need to develop high-tech capacities, as you cannot depend on the US to provide your security needs for you. So there is clearly a security element in a host of their industrial initiatives, such as in space. In the US, their technology policy is shaped by security requirements. Their aim is quite simply, as a minimum, to be world-class and usually to be world-leading in every major technology. That is part of America's security strategy, and it leads to massive federal US support for insurgent technologies on the way to the market, with funding that takes them much closer to market than we have historically done in the UK. It was actually an argument way back in American history in the Federalist Papers at the time of American independence. That's when Alexander Hamilton saw a big positive role for government, and Thomas Jefferson believed in a nation of sturdy, independent yeoman farmers with very limited government. And when I had the opportunity of the past few years to observe American science, technology, and industrial policy close up, I concluded it's very simple. It is a Hamiltonian state hidden behind Jeffersonian rhetoric. And by and large, it works. And indeed, my view is that it is, if you want to see how the big general purpose technologies get their way to market, it happens as a result of either a very clear security need or because of the kind of surge of irrational optimism that Schumpeter so brilliantly describes. And rarely can it be seen as just a matter of government doing the upstream pure science and then leaving the market to it. Now, what matters here is that this discussion is that for the security services that we use, that the Americans provide to us, are a result of American industrial policy. The Germans and the French clearly see a security need for their technology policies. And it has left us looking to them surprisingly naive about the role of industrial policy and technology. It has given us it has enabled us to be strangely kind of fastidious and detached about these decisions, because essentially we enjoy the fruits of American industrial and technology policy without having to take the kind of decisions which the French and Germans take. Galileo is a classic example of all these issues. The Global Positioning System, or GPS, we're all familiar with. First of all, it is a spin-off from an American military program, NavStar, the navigation system using timing and ranging, planned from 1973 and made publicly available in 1983. And there have been several improvements to the quality of the civilian use signal that I'm sure there's probably hundreds of devices in this room as we speak using GPS. But that, of course, does not have the same quality and the same accuracy as the precise military positioning service that GPS delivers. And there has always been the fear, especially on the continent of Europe, that in a conflict, the US might turn off the civil use of GPS. Hence the slow and messy development of a European capability, Galileo, which the Americans were very wary of, as it was seen as an alternative to the system that they controlled. The fact that Europe at one stage had got Chinese investment to help fund it did not help. And most serious, the original plan involved using the identical radio frequency as GPS, so jamming it would also involve jamming America's own signal. After a long and messy history, the attempt at a largely private model for Galileo was abandoned, and with it China's role. And instead it was agreed that Galileo should operate on a separate radio frequency and not in conflict with the US as a result. This, I think, incidentally, is a vivid example of a dilemma that I'm going to come to later. For the Americans, the dilemmas of the hyperpower. They have made one of these technological advances. What do? It's a fascinating dilemma for them. Do they share it and ensure that they are the custodians of a universal service? Or do they hold on to something special for themselves and accept that then their competitors, be it Europe or China, will develop an alternative technology? That is regularly their dilemma as these technologies mature. And of course, it in turn presents us with a junior version of this dilemma. Do we stick with the American superpower, with their model, or do we instead play a role with the alternatives as they emerge? Now, when I arrived as minister in 2010, the Brits were pretty fed up with Galileo. Despite the fact that, satellites, as I say, I declare again my interest is actually a contractor to, as part of the Galileo program. The Department of Transport, who were then the lead department, didn't like it because of its long, slow, messy history and didn't see the point of it. They thought GPS was fine. But fortunately, responsibility was transferred over to BIS in 2012, and I think that meant all of us, including the excellent officials that came with us, had an opportunity to look at it very differently. But the real people were hostile with the MOD. And I can still remember the dispiriting experience of the MOD briefing on Galileo, which basically just made fun of it. And they made fun of the elaborate European committee structure around it. The Europeans wanted us to play a role in ensuring security for the Galileo service and its signal, but our security services initially refused to play any role in that. Their view was Galileo links like a sieve. We'd never have any security use for it. What's the point of putting scarce manpower and effort into it? And these fears were confirmed when at least one key item of equipment had to be removed after discovering concerns about its security being compromised. But nevertheless, France does use it for security purposes, hence the indiscreet remark attributed to the head of OHB, the German company making the satellites alongside Surrey satellites, according to WikiLeaks, who called Galileo, quote, a stupid idea that primarily serves French interests. But I regret that we did not do more in it at first. And one of the key advances that we made when we were drafting the main document, the National Space Security Policy, finally published in April 2014, was that by then we did get a more wholehearted commitment from our security services to engage with security issues around Galileo, far more constructive than would have been conceivable even a few years earlier. And I believe that this is because our sustained involvement in Galileo actually showed what its potential is. Because these systems, and there are many people in this room who are far more expert on the science and technology than me, it's basically a modern form of Harrison's great chronometer, enabling us to link time and place. And of course, the atomic clock on which it depends was originally a British invention. And the more precisely we know where we are, and the more precisely we know the time, the greater we're able to do everything from landing planes at shorter intervals, even when it's foggy, through to removing the clutter around a railway track as we know where the train and each of its carriages is precisely by satellite location. Driverless cars will depend on it. And what matters here is, first of all, the more satellites you've got up there, the better. There is a cumulative process of improvement the more satellites you have on the case, so you can aggregate and gain precision as a result. There are some special additional features of Galileo which you don't get from GPS, such as the search and rescue function, where for me, showing my age, there's just a hint of Thunderbirds to what it's going to be able to do, getting information about where you are and sending you back a message, don't worry, we know where you are, help is on its way. That's going to be part of the capacity of Galileo. Also, the very fact of a competitive challenge to GPS drove the Americans to improve access to GPS with more precision and more openness than they might otherwise have done, just because there was an alternative coming on the scene. And above all, the regulated public service is a key advance, because what this is about is security for the locational information used by key public services. And security comes in many forms. And of course, if you're sitting in the MOD, you're thinking quite understandably of a special services operation needing to have secure satellite comms. That's one very hard and very significant form of security. There's also the day-to-day security needs of the emergency services. The security needs of knowing that the police can communicate with each other with a reasonably secure signal. There is the great story of when Churchill, in his dotage, in his last years as Prime Minister, couldn't hear very well what was happening across the cabinet table. They installed a primitive microphone speaker system so that he would have the contributions of his cabinet colleagues magnified to enable him to hear them more clearly. And it was all going fine. He really liked the service until a taxi driver driving down Whitehall pulled into 10 Downing Street and said, I just thought I should let you know I've been listening to the cabinet discussions on my taxi radio. So they realized that there was a need for some security. And our view is that this fairly secure signal, not full military security, but fairly secure signal, is a fantastic market opportunity. The public regulated signal was indeed identified as a key market opportunity in the space innovation and growth strategy. And indeed, in just over 2 years ago, in July of 2013, I was able to announce £6 million of public investment as the second stage of a technological incubator for technologies which use and exploit the secure service offered by EU's Galileo satellite navigation constellation. And that led to the development of novel receiver technologies, ways of improving the security of encrypted services. And that 6 million of public investment has already delivered 100 million pounds of commercial investment in developing services around this, around Galileo. And and just in passing, it is a useful piece of counter-evidence for those who believe that we simply cannot use public money successfully to deliver technology strategies. You can. You don't always get it right. You have to accept you're going to make errors, but it can work. And on this occasion, I greatly benefited from an excellent piece of work, which was the National Space Technology Strategy for the UK, which was absolutely the commercial sector defining their technological needs, where they might invest, the scientists defining their needs and what was needed, the public sector then thinking about what we could invest in and coming up with a much more coherent space technology investment program than would have been possible if we'd all been doing it on our own. And I remember commissioning to do it. It's an excellent piece of work by the former rector of Imperial, Keith O'Nyans. So it can be done. You don't always get it right, but it can be done. Now, let me now, I've touched a lot on Europe, and I've talked about America and the special relationship. Let me just cover the other major space players. Russia, for a start. And although nowadays, as there are increasing tensions with Russia, we think it's extraordinary that we're using Soyuz to launch quite sensitive satellite systems. It's worth remembering that 20 years ago, this was an absolutely key part of the end of the Cold War. Russia had got enormous stocks of ICBMs and what was going to be done with them. And this was a modern form of beating swords into plowshares. These decommissioned ICBMs are one of the main launch systems now used, especially for smaller satellites. So part of the engagement with Russia was to find a use for their missile technologies, given that they existed. And hence, for example, the agreement for ESA to use Soyuz and for Soyuz launch systems to be launched from Kourou as well as Baikonur. Indeed, it is now the main way of getting astronauts up onto the space station. And whilst we were engaging with Russia in this way to find civil uses for their military launch capability, I have to say, meanwhile, the partnership from America, certainly from my perspective on the civil side, was sadly not always functioning well. And for me, one of my most dispiriting moments was when NASA withdrew at very short notice in 2012 from the ExoMars program that we had developed in the European Space Agency for getting a rover vehicle onto Mars. And I think the Americans thought if they did that, it would be the end of the European Space Agency's Mars program. And who knows, perhaps there are even some people in the US who didn't want to see ESA developing a Mars program. But ESA, with the support of many member states, including the UK, Agency, and we'll be using Russian support to get the Mars rover to Mars. And interestingly, and this is something which we are developing at Stevenage, this is an interesting example, incidentally, of how it's not always the case that civil lags behind military uses. By and large, in these areas, because essentially Mars rover vehicles are remote-controlled vehicles, in the military, there is still quite a strong ethical presumption that when it comes actually to firing a weapon, there has to be human intervention. So what you have for military use is remote-controlled systems, and the American rover vehicle is remote-controlled from the US, and takes a long time for the signal to reach the Mars rover, to instruct it to move 10 centimeters to the left, get a new picture of where it's got to, send the message back, get a new instruction. The European Mars rover system that we're developing is going to have much higher levels of autonomy. So it's going to be able to travel much further doing a Martian day because it is less dependent on instructions from Earth about where it should move and how it should move. And you find some of the most significant advances in fully autonomous systems are being made in civil areas rather than military areas because we are more comfortable with autonomy in civil uses. And indeed, that largely British technology for the Mars rover, I was very pleased to see for 18 months ago, spent a few months inside the reception area of the Treasury, as the Treasury came to understand and appreciate space. I said mischievously it was there to discover signs of intelligent life. So there is a European capacity, and we've ended up, as a result of a NASA decision, doing this next Mars mission with Russia, not with the US. There's India, a fantastic opportunity, and the Indians have an extraordinary ability to use technical ingenuity to deliver low-cost access to space, and I'm a great admirer of their space system. I think there's not time for me to go into another one of my grouses, which is this endless narrative you get in some parts of the media. What are we doing providing aid to countries that are so rich that they have a space program? A space program is not a luxury. A space program and satellite data is an essential infrastructure, even more essential for a country that does not have other forms of infrastructure. If you want to get educational programs out to remote schools in Africa or India, satellite is a very good way of doing it. I remember a conversation with the Indian education minister who told me that he gets all these statements from regional governments about schools that they are supposed to have built in accordance with federal funding, but the only way he could check whether the school had actually been built was ask for them to give its coordinates, and he would then use a satellite image to check whether the school was actually there or not. They need these services for a variety of reasons. China is the key player on the scene, and this is the right place to talk about China and its science and technology strategy. And China has got a very clear strategy, which is that they are developing both a space station and they will be developing a lunar base. And the kind of extraordinary long-term planning that they do in China, scrutinizing, of course, and learning very much from what we do in the West. I remember sitting at a meeting with the head of the Chinese Space Agency, who said to me, Minister, we've obviously been planning for our lunar base, and we've been planning the different technologies we need to operate our lunar base. One of the technologies that we'll need to operate it efficiently is 3D manufacturing and printing. We see that you in Britain are very good at 3D manufacturing and printing. Will you be our partner in the 3D manufacturing printing function on our lunar base, please? I never had NASA approach me and have a conversation like that. It was very clearly and specifically done. And for me, I think that the big moments, as we look 10, 20, 30 years ahead, the big moments will be as the International Space Station is decommissioned. It's been delayed, the decommissioning, but it will happen. Again, not the cynics, but just the America used to be skeptical about prolonging the life of the International Space Station. They're now supporting an extra 5 years' life of the space station. One interpretation of that is they want to carry on commissioning launch and deliveries to the space station for long enough for SpaceX to become a viable commercial model. A perfect legitimate example of industrial policy thinking in space and technology. If you want to get your commercial models going, they need a nice big fat customer giving them contracts for as long as possible. So but even so, the space station is not going to get much beyond the late 2020s. For the Chinese, meanwhile, we may well see that its successor is a Chinese space station, and we must also expect that the next person on the moon is Chinese. In fact, if they're smart, it'll be a Chinese woman will be the next person on the moon. And in terms of the kind of Sputnik moment, I think the moment when the next lunar mission is with someone from China will be a significant challenge to the West. Now, the good news, however, is that the big projects, the really big projects, and I would certainly classify getting a man to Mars as a big project, and a lunar base is probably such a project, are so big that they need partnerships. No one country can do it on their own. But they are not so big that they need everyone. So you have got a game of musical chairs going on here. What are the partnerships that will shape these emerging opportunities? And I say this in sadness, not in anger. And I understand the challenges of being a hyperpower. The Americans find it quite hard to cooperate in science and technology projects which they do not lead. They're not present at the Large Hadron Collider, which began as a European project in competition with an American project that didn't come to fruition. They're not partners in the Square Kilometre Array. So what are the prospects of America leading a genuinely collaborative effort with major partners on this type of thing? Is there a risk, chance, that the future will be a Eurasian project, a Europe, Russia, China project? What would the UK think about the world's biggest global projects being Eurasian? What would America think about this? These are the big strategic questions that I think will come in the decade ahead. Now, finally, because I know I've talked a lot about the strategic issues, and for me, these were the issues that were in the background of so many discussions. I'd just like very briefly to talk more about the specific security issues and then come to an end and give you time for questions. The National Security Strategy identifies the following as a significant security risk for the UK, and I quote, "Severe disruption to information received, transmitted, or collected by satellites," end of quote. And this comes in several forms, and again, how we respond to these challenges, you immediately find is where civil, military, diplomatic issues all come together. There's first of all space weather risk, the risk of a Carrington event, first observed in the 1850s here in the UK, indeed at Kew. And in fact, because of solar cycles, we have been due some events, maybe not quite on the scale of Carrington, but we have been due some very intense solar activity over the last couple of years, which hasn't really materialized. I'm sure there's an astrophysicist in the audience who's about to correct me and tell me I've got all this wrong, but we certainly had in our list of risks for the London Olympics, one of our risks was a solar storm knocking out all broadcasting coverage during one of the big events. And fortunately, those type of risks have not materialized, but they could do in the future. Though I have to say, the satellite companies all maintain that that their modern satellites, their latest satellites are pretty robust. The worst they would do is turn them away from the sun, switch them off, switch them back on again after a week or two, which, as we all know, is the solution to every serious software problem. If there were to be a problem from space weather, probably are not less likely to be satellites, it's more likely to be power lines, and indeed the worst examples we have are disruption in Quebec, which was heavily because of pressures on their power lines, and for reasons you guys understand and I don't, this particularly affects east-west power lines, and as England has relatively short power lines now as a north-south, we are less at risk than some other countries. So there's space weather. Then there's cyber attack, and cyber and corruption of for example, signals from Galileo and GPS, so that you are led to believe you're in a different location than you're actually in, or that the time is fractionally different than what you think it is. And I understand the hazards of all this. My constituency, my former constituency, Havant on the south coast, had a lovely island, Hayling Island, next to Portsmouth. And for most of the war, Hayling Island was dressed up to look like Portsmouth for the purpose of attracting German bombers to bomb Hayling Island, not Portsmouth. So Portsmouth was kept dark, lights were set out around Hayling, roughly matching the pattern of lights 3 miles away at Portsmouth. That was an early low-tech version of spoofing the signal. And we do now face those type of risks, and it could lead to financial fraud if you can make tiny adjustments in the timing of financial transactions. It's very relevant for the Internet of Things. It's very relevant for the security, for example, of driverless cars. Imagine a program where you instructed every BMW to drive at 70 miles an hour for a minute and then come to a stop. That would do a massive amount of disruption. Those are the type of anxieties. And although those are clearly a problem, I have to say that's also an area where we in the UK may have a commercial opportunity because of our expertise in cybersecurity. I drafted this before talk happened. Because of our expertise in cybersecurity, this may be an area where actually we can sell our products on the basis that they are more cyber secure than their competitors. But then most sensitive and most delicate, of course, is the physical knocking out of a satellite. And that could either be as a result of deliberate attack or, of course, a result of debris knocking it out. And that's why space situational awareness is crucial. The challenge of debris is becoming increasingly significant, and there are basically, even if you get good advanced information that you may be hit, so move out of, there's a risk that something will come within a kilometre of you or within 100 metres of you. Every time you manoeuvre your satellite to get out of the risk area, you use up precious fuel and shorten, therefore, the operational life of your satellite. The obvious thing to do is to remove space debris. And the technologies exist to go up and move space debris. The obvious thing to do is to nudge it into an orbit which brings it back into the atmosphere and causes it all to burn up. That is, I'm told by the experts, technically possible. But it's actually got some quite significant problems. The first problem is that the legal regime in space is not the same as the maritime law of salvage. And whereas if a ship is at the bottom of an ocean, a salvage company is entitled to go and try to salvage it, every bit of space debris belongs to someone and is their sovereign property. You are not allowed to touch it without their permission. And secondly, most of the technologies that you would use for getting close to a small bit of debris and giving it a nudge to send it down into the atmosphere to burn up clearly have a dual use in anti-satellite warfare. So this problem is a problem where there is a technical solution, but very serious legal challenges in actually deploying it. We in the UK have got a very significant capability at Findingdales, which is actually, again, a classic example of the problem I was describing at the beginning and which pervades space policy. It's part of the US ballistic early warning system. Incredibly accurate. They're supposed to be able to track a tennis ball 3,000 miles up. So they have got a really important technical capability. The story that they tell you at Findingdales, which is perhaps apocryphal, is of their chief technician being phoned in the middle of the night during the height of the Cold War in the 1970s to be asked to advise the Americans who were worried that they were observing a Russian missile launch aimed at them. And it was the people at Findingdales, who were the experts, who assured the Americans that this was a meteor shower and not a Russian missile launch. But it was only, they say, when the chief scientist at Findingdales was put on the line to the White House to assure the White House that this was indeed a meteor storm, that the American anxieties came to an end. So these things do have a very significant role. But they are for security purposes. And what we have now done is we've now recognized that we need to create our own domestic capability which would enable us to track these objects, and are working on this with, with France and Germany to identify and tackle this problem. Because, again, ESA doesn't feel that it can fully rely on the American military to tip them off whenever there is a problem and in sufficient time. And let me quote on the record Jean-Jacques Dordain, when giving evidence to the Commons Science and Technology Committee in 1913, asked about this problem of space debris. And I'm quoting him now as follows. As long as we don't have any system in Europe, we are using data coming from the United States. Classic start of the problem. The problem is they're giving us data on short notice, unfortunately. I can give you an example of that. It was Christmas 4 years ago. I was told during the night to Christmas, oh, by the way, debris may cross the path of our satellites 2 days from now, so you'd better check. I would have preferred to get that information much sooner. That was Jean-Jacques Dordain. That's why there was going to be the creation of a European special situational awareness capability that has not previously existed. So, what do I conclude from all that? And let me just briefly suggest 4 threads to all this. For us, we are in this delicate, excruciating, powerful position of both having the special relationship with the Americans and also being partners in Europe. And it is an endless, it's both an endless source of difficulty and complexity, but it also offers us an extraordinary role. And of course, if we are smart about it, then each side values us more because of our relationship with the other. And I think one of the reasons why the MOD's view of Galileo shifted after 2010 was they began to see that if we could use Galileo, it would actually enhance the accuracy of data, and it might even, including even with the with the Space Situational Awareness Program, enable us to generate data that was of use to the Americans, that would increase our leverage and value to the Americans. Secondly, there is on the horizon, I don't think I would particularly welcome it, but I can see it happening, a Eurasian scenario. I focused on this in my talk because of ITAR rules and the rules on what you can export and who you can export to. America ends up creating a non-American technology world in a host of different areas. One of them would be space, and ends up with sometimes more as a result of adversity than anything else, leading to a China, Russia, EU cooperation in space, which might then have greater capacity than the US. And that, of course, would present enormous dilemmas for the UK. Thirdly, at the end of all this, partly because of our awareness of having anything like an industrial policy, and being happy to essentially to piggyback on other people having an industrial policy, we've ended up with surprisingly little UK capability of our own. Almost all of our capability either comes from the special relationship with the US or comes from partnership and membership of ESA. We are in the situation where Nigeria can take a sovereign decision to image the UK, but the UK cannot take a sovereign decision to image Nigeria. We do not have our own Earth observation capability. All of it depends on others. And that's why I come back to my vision of the recreation of some kind of full UK indigenous capability. I don't think that this special relationship will come to an end, but it'll all be a matter of priorities and timing, and someone will phone up about some obscure problem of a British hostage taken somewhere, and the Americans will say, yes, we could get you that. Yeah, but the trouble is there's a big crisis on with Iran at the moment. You come back in 48 hours. That's the kind of scenario which is more credible, and where the fact that we do not have any of our own Earth observation capability, I think, is a significant issue. And then finally, from the underlying dilemma, and there is no resolution of it, but again, it became increasingly clear to me during my time as a minister, is that space has this unique feature that from the point of view of the military and the security agencies, it is the ultimate high ground. It's the high ground that enables you, above all, to survey the scene and command an area. From the point of view of the lawyers, the space is the ultimate global commons, where everyone has a right of access and where there are no constraints other than those laid down in treaties on militarization. reconciling space as the high ground for the military and space as the global commons for all of us is a challenge that all of us wrestle with and none of us have yet resolved, and I doubt if it ever will be, but the crucial thing is to recognise this dual use. Thank you very much indeed.
The applause tells me that you all agree with me that David has continued the tradition of the Briscoe Lecture in delivering a really stimulating and interesting lecture. So thank you for that, David. He's taken us on a tour from looking at the early history of space from the UK perspective, through the special relationship with the US and the impact that's had on our relationships with Europe. To a fairly exciting and possibly quite challenging future. And somehow, on that journey, he's managed to insinuate The Hitchhiker's Guide to the Galaxy and also Thunderbirds. So we had a bit of fun on the journey too. I think as he's made very clear, we're facing a future where space will play an increasingly important role in our daily lives in terms of navigation, transportation, and communications, to name just a few. And in talking about the security threats, I feel most qualified maybe to talk about the middle one of these threats, the cyber threat. It's one of the strengths of ISST that we've played a really significant role in the academic research program in cyber security. And I'd like to commend the National Space Security Strategy document that David held up during his talk. It's got a really nice coverage of some of the key issues in terms of space security, but it also reports on the first cyber attacks that have happened, in fact, way back in 2007 and 2008, on 2 US satellites. And those cyber attacks were actually basically mounted through the internet, as you might expect, but actually through commercial ground stations. So it wasn't attacks directly on the satellites, but it was actually through commercial ground stations which were connected to the internet. And that really brings me to a theme which is at the heart of what the Institute does. We lead the government-sponsored research institute in trustworthy industrial control systems. And our remit within that is to develop an understanding of the threat to critical infrastructure. And I think David's made a compelling case that going forward we should see space as part of that remit. As well as understanding the threat, we're trying to develop novel, effective defensive strategies. And that spills over into interconnectedness in the future between infrastructures as well. Many of those connections between different infrastructures will be mediated through space and through satellite communications. So David's wonderful talk has actually presented some exciting new challenges for us to take away and think about within the Research Institute. So I'd like to finish there and just ask you once again to join me in thanking David for a wonderful lecture. As he indicated, he's willing to take some questions. So we'll now take questions. The proceedings are being recorded, so please, if you want to ask a question, raise your hand and wait for a roving mic to come to you. We'll take questions for about 10 minutes or so. The first question I saw was right at the back there.
Hi. Given the lack of Concorde now on supersonic flight, there's been much said about potential suborbital flights, and given the massive ramp up in the human population going forward, and the need to get people around quickly from A to B, how do you see that playing out, and who will take the leadership in potentially mass suborbital flight?
Right. Do you want to collect several questions? Yeah.
Yeah, so there were a couple in the middle. There's the gentleman with the check shirt, and then Joe right at the back there, please.
First of all, I'd like to thank you again for the talk. It seems that Britain's stance on space security currently is very closely intertwined with US defense policy and the course of action undertaken by ESA. In particular, I mean, Britain seems unable to make a sovereign decision without American support, without an executive decision, without American and European funding. I mean, it seems even difficult to have a constructive discourse about space security without referring to Jeffersonian rhetoric. But we do know that the spheres of political power influence can evolve as a function of time. And maybe there will be a similar talk in a few decades from now where the equivalent speaker would be quoting Confucius or Pushkin or even Tagore. So my question fundamentally is, what can Britain do given its wealth of scientific research and development into this issue, to try and increase its influence and clout on this very crucial matter for the future?
Thank you. Joe.
Hi. At the end of November, there's going to be, of course, the very important climate conference in Paris, at which countries will, we hope, be committing to reducing their CO2 emissions into the future. I'm wondering whether you see it as at all feasible or possible that countries will agree to adopt some sort of space monitoring system of the emissions, either from a governance perspective or a technical perspective.
Yeah.
And there was one more question that we'll take in this batch, which was just from this row here.
Hi there. I noticed that there's a slight trend away from what appears to be manned space flight. We have the ISS going away, the space shuttle's gone. There's increased sort of autonomy you mentioned in terms of the Martian rovers as well as NASA. Whereas India and particularly China really ramping up their sort of manned flight. I guess, do you see that as a trend between the sort of Western and Eastern powers? And I guess from a personal point of view, as a relatively young scientist, what are the chances that I could be an astronaut?
No. Right. On those four, I mean, first of all, yes, the suborbital flight, the kind of reaction engine is what would be capable of doing that. I mean, at the moment, and several of these technologies, of which that is the one I'm most familiar with, can be used for putting satellites into low Earth orbit, but also can be used for getting you from here to Sydney very fast. So they are, I think those technologies are on the horizon. On the UK and its capacity, well, I rather agree with you. And my view is that technological change and the way in which British expertise is developed in the next decades, as I was trying to imply in the talk, actually I think gives us an opportunity. I can see a moment not too far off when a British Prime Minister facing a crisis, it needn't be directly military. Imagine a group of British hostages have been taken in a jungle in Colombia, would be able to commission the launch of small satellites that would be over the area and would give him accurate data in very short notice. And I think we are not that far off that. At the moment, and the system is not completely defective, at the moment, be it military or civil, there are systems that enable you to access other countries, and pooling other countries' resources is not a sort of national humiliation. And there's this great thing, the Disasters Monitoring Constellation, Commission, which actually allocates passing satellites to a problem. When we had the serious flooding, was it last year, the year before, we said we need to monitor the extent of flooding in southwest England. If you have satellites overhead, we need the images, please. And the DMC, an international agreement, chipped in, and we got the images we needed. So, I mean, it's good in a way that other countries help out, but yes, I can envisage a future where the UK gets that sovereign capability. The climate change conference, a very good point. I simply, I'm not close enough to it to know what the politics are. I do know that there are people, again, in the space community who believe that they have technologies that really do help because of the subtle changes in the spectrum from the atmosphere, depending on the amount of carbon dioxide and even where it's being emitted. And I remember having this conversation with Adair Turner few years ago when he was writing his report. And Adair, and I was surprised because Adair is a really sophisticated guy and a good friend. And I said to Adair, look, aren't you interested in these kind of technologies that enable you to monitor carbon emissions? And he said, no, we've got a pretty good sense of how many heavy ships are unloading coal on the ports of China. We've got a really good, pretty good picture of their output of coal from their coal mines. We don't need satellites doing that kind of stuff to calculate carbon dioxide. But I think that there is a, I think space and satellite services can help. And the rise of manned missions, yeah, I think it's, I think the interesting question is kind of why America is losing interest. I mean, everyone else is gaining interest. And the asteroid capture model, I think I don't know how long the asteroid capture as their crucial national space priority will survive. It does seem to me an odd strategic priority to have. Someone said they will soon define the moon as a very large asteroid. And then we'll be back on track. But it is a unusual priority to have. But sophisticated people in the US will offer you an explanation of it. But I think for most countries, it's a space station, it's a lunar base, it's a Mars mission.
So a question at the front here, please, if one of the... and then there's one at the back, so I don't know if you can share responsibility there with the microphones.
David Omond, also a visiting professor at King's College London. Thank you for the upbeat, positive, very welcome account of the opportunities. I wondered what lessons you had drawn from the experience of the biggest ever British space program when we built our own maneuverable space vehicle during the Cold War to defeat the Soviet ABM system around Moscow, called Cheveline, the scar tissue you can still see in the scientists in the Ministry of Defense.
Yeah.
And then the question at the back, please.
Okay. I think it's rather unlikely that we'll ever achieve independence of operation of space operations with the US because of the way NASA is structured. It's basically led politically and financially and militarily, and the money comes later. Whereas with ESA, the technical director leads ESA, and then they find the money. We're far more likely to have an independent Galileo type of GPS, for want of a better expression, and missions which we are interested in.
Okay, we'll take one more question in this group, and that will be the last question, and it's over this side, I'm afraid.
You made, during your remarks, I think 2 points which might superficially seem to be in conflict with one another. I wonder, can you resolve them? You noted at the beginning that British expertise in satellite technology is the result of a happy accident, that they didn't get into launch technology. But you then also noted that US prowess or perhaps the driver for their industrial and innovation policy is due to their concerns to be militarily and security independent, which I think is a thesis that Mariana Mazzucato has developed, which helps make them a real powerhouse of R&D, which I think the UK probably still has some ambition to be in the same league as. So policy or no policy, which is the best outcome?
Right. I have to say on Cheveline, I know very little other than the lesson that and what I'm envisaging is not that there are really high-tech capabilities that we can develop independently of the US. It's more that what I find frustrating is that there are kind of middle-range capabilities that, and you would know, that aren't the highest security level, about which I don't claim really to have any expertise, but they are it would be useful to have. And that was why the MOD weren't interested in Galileo. It wasn't quite secure enough, though for many of the day-to-day functions, including some of the security issues you were describing, it's actually quite handy. And I think Earth observation. And what I would love to see is across Whitehall, my view is that across Whitehall, there are lots of departments that are using Earth observation services, which are being purchased randomly. If you aggregated all that, you would actually have the funding for a UK Earth observation capability that DEFRA could use when there was flooding, and that the DEFRA could use for crop monitoring, and that the transport could use for monitoring traffic jams, and everybody, and indeed, in some circumstances, the MOD would use as well. So I think the lesson I take from Chevelin is we don't have to rival the Americans at the really high-tech stuff, but there are other things which are quite useful that we don't seem to do, and which I think we should be able to do. On NASA, yeah, and NASA, the thing that's happening at the moment in the US, and it may change, and it would be good if it changed, but the tensions between the executive and Congress and the divisions within Congress do make the life of people running America's executive agencies very complicated and very difficult. And part of the reason for the shifts in policy is there's a kind of endless process of trading off between the President and Congress, which makes it hard to predict sometimes where they're going. And then on this kind of challenge about industrial policy, the Americans try to do everything, which is a rational strategy for the hyperpower. And the economists would say they're big enough themselves to capture the gains from being ahead in these technologies. They can be internalized within the US economy. If Denmark made an amazing scientific advance, most of the benefits would be enjoyed by consumers outside Denmark, and quite possibly would be developed by companies outside Denmark. If you're the US making a technological advance, you've got a better chance of capturing the gain. So the economic environment helps shape the way you do this policy. I think for us, it has been, we have been so wary of, quote, picking winners, that we have not been willing to set out a view about the technologies we should invest in. And my view, and I came to this and set this out in a series of speeches in 2010, 11, and 12, where I was deliberate and which, trying to take my party with me, and I think they did go with me. I think it was a slightly different thought process from Vince's, though Vince was going through a similar thought process, was we have limited money. So what you have is a kind of, you have a science policy which is very liberal. You don't try to tell individual scientists what subjects to research. And you have at the other end of the scale, you have a market economy which is also liberal. You don't tell consumers what to consume. In the middle, when it comes to the slow, expensive journey of a scientific discovery into a technology and into the market, they do need public support, and we have limited public funding, so we can only support some of them. We can't do everything. You have to be selective. And that has led to what I call the 8 great technologies, which is an attempt to identify technologies on the basis of, it wasn't my personal view, which wasn't of much value. It was the scientific advice, a distillation of the scientific advice, the technologies where we both had a UK capability of global standard, and there was a significant global market, and we had the opportunity of doing some of the business development ourselves here in the UK. And satellites was one of the 8 great technologies. Satellites as both collectors and communicators of data. So even though it started as a series of accidents, my view is that and these things are often accidental. How you get an innovation started, you can't control all of that. But once you've seen you've got a strength, it's perfectly reasonable for governments to develop it. The story at Surrey, of Surrey Satellites, is that the governing body of Surrey University wanted sort of tourism studies or something to be their strength. And there were just some entrepreneurial space engineers and scientists, notably the great Martin Sweeting, who just got on with doing satellite stuff and created a satellite company. Nobody had sat at the top of Surrey University, apparently, and said, I think Surrey should really become a leader in satellite space technologies. It just happened. So that can be the origins, but it doesn't alter the fact that once you've seen it happen for whatever reason, there's a legitimate role for government in helping it on the long way to market.
Thank you very much once again.